Hey, everybody. This is Todd Albert coming to you live from Boca Code. Well, from my home office, but Todd from Boca Code coming to you live from my home office. We're kicking off a three-part series this week on game development, starting today with fundamentals. On Wednesday, we're going to jump into rapidly prototyping games using pre-built assets, kind of assembling those assets into an actual game. And then on Friday, we're going to jump into customizing your game using programming. So let's get started. First, I want to take a moment here to find my live channel. Sorry. Okay. Got to bail on something real quick. Bear with me for one moment. Sorry. Trying to use two screens here to do this, and my system is not loving it. All right, there we go. So first, I want to take a moment to recognize our sponsors, Boca Code, which is a new code school in Palm Beach County, which is started by and run by actual developers and professors, give you the best training for your career. And also by Palm Beach Tech. If you're not a member of Palm Beach Tech, highly recommend check it out. PalmBeachTech.org. They've got an amazing Slack channel, palmbeachtech.org/Slack. You can post your resume there. There's jobs, search for local companies, tech companies, etc. Really awesome. Boca Code, join us on Slack. If you go to bocacode.com, you could check out some of our upcoming courses. You can join us on Slack with a single click. We hope you'll take a moment to join us. So let's get rolling. Pop myself on here and start us up. So we're going to be talking about fundamentals of game development today, which really boils down to, what goes into developing a game, right? So let's break it down. The answer is lots of stuff, right? There's many aspects that go into a game. So there's the story, and this is kind of an overview of what I'm going to be speaking about today. So I'm not going to go into any of these in depth now. I'm going to get into those coming up. There's the level design, right? How to design levels. There's assets. What are some of the 3D or 2D assets you're going to use? The artwork, music and sound can become very important. The user interface, or sometimes referred to as a heads-up display. Behavior, both of maybe your enemy's behavior, the type of game, is this top-down or first person, etc. Game testing, and then eventually marketing and deployment. And I want to point out, there's all of these aspects here that go into game development. And what happens, oftentimes I get people telling me, hey, I want to be a game developer. And then they go to code school, or they go to art school, or they do something. But there's so many different parts of game development. And to create a really top-notch, the next hot game, you really need to be thinking about all of these aspects. And usually to make a really good game, you have a team of people that are working on these different layers, these different aspects of the game. So don't just say to me, hey, I want to go into game development. Think about what you want to do. I talk to people all the time, well, I just want to test video games, right? They just want to sit around in their underwear and play video games. But as you're going to see when we get to that, there's a lot more to it than just that. So let's jump right into the story. And for a lot of us that have been playing games for a while, we remember the classic Super Mario Brothers. What was the story? The story was the princess was kidnapped by a freaking turtle dragon hybrid thing, and we had to go rescue her, we being Mario, we being the hero, right? So what goes into a good story, right? And not every video game is going to have all these aspects of a story that I'm going to tell you. Some of them are just, break as many bricks as you can, sometimes it's just that simple. But to have a really engaging story, there's 7 elements that a really engaging story will have. And this applies to video games, this applies to movies, books, everything. And this comes from Donald Miller. So number one, you have a hero, and that should be you. It should be the person playing should be the hero. Number two, that hero has to face a problem, right? His princess was kidnapped and he's got to go rescue her. In the best stories, the hero then meets a guide, okay? The guide is your Yoda. The guide is your Obi-Wan Kenobi. Okay? This is the person who's going to tell you that, or person or character, I should say, that's going to help the hero guide them. It's going to say, hey, here's what you need to do. They're going to actually give them a plan. Here's how you go find the princess and rescue her. And then calls them to action. Go, Mario, go. Give us, go rescue the princess. For a story to really be engaging, you also have to have the possibility of failure. Your hero needs to be able to fail on this mission. In the case of Super Mario Brothers, you either rescue the princess or you die trying, right? And that's common in a lot of video games. There's, it's the hero dies or makes it to the end. But sometimes there could be race conditions where you're saying you need to rescue the princess before she dies, right? And, and then there's the possibility of failure. When you get there, she may be already dead. So, keep that in mind. There has to be the possibility of failure and the possibility of success. You can win. The best games are ones in which you can win. Although, again, there's exceptions to this. Endless Racers, for example. There's a goal in mind. I'm escaping the things chasing me, right? There's a possibility of failure. They can catch me, but there is no necessarily end. So there's always, exceptions to some of these rules. But for a really good story, a good story with an ending, you have to be able to either succeed or fail. So then we get into level design. And again, I'm going into each of these elements here very briefly, but I want to take a moment and tell you that at Boca Code, we're actually going to be offering a 1-week level up course on game development and virtual reality. So you're actually going to go through all of this stuff in much more depth. We're going to actually create a game from start to finish. You'll end up with a working game to take home on your phone or your laptop, and we'll play around with VR. We'll show building VR games or mixed reality games. But it's a 40-hour course, 1 week, where you go through all of this. This week, what I'm doing is just giving 3 very short 1-hour courses just to whet your appetite. But if you really, for some of you that'll be enough. But if you really want to delve into it, like I said, we're going to be offering in both August and December a 1-week course on this. That's 40 hours. Okay, so level design. What makes good level design? And I base this on Dieter Rams' principles of design. For those of you who come from the design background, you might recognize some of these from that. But first and foremost, a good level should be fun, right? It should be able to convey some of a story without using words, right? Well, the first video game I ever played, my father brought home a workstation from his office computer, and the only thing you could do was dial into the mainframe, and then the only thing I had access to was I could write code, which is how I first learned to code, and there was a game. It was an adventure game. You were standing in front of a door, and it was all just word descriptions, verbal descriptions, and you would type, open door, turn east, walk south, walk down driveway, check mailbox. You guys are familiar with the Zork and adventure type games. It was of that type. But today we want our levels to tell us a story just visually. We want to convey a story, right? So this screenshot here is from a game called Mirror's Edge. They have beautifully designed levels. And, here you could see immediately, okay, we're in a city. We're looking at the city from a rooftop. There's construction going on these towers, right? So already you're starting to piece together this story just from the visuals here, right? And you might get a sense that, hey, I'm going to need to be jumping around on those rooftops. Number 3 is to have a clear goal, right? on your level, you want a clear goal. I need to know, okay, at the end of this level, I need to get to a particular place, or I need to chase the guys in that are in the van, whatever it is, and catch them, right? But there's not a clear solution, right? Even in Super Mario Brothers, you're running from one end of the screen to the other. There's only like kind of one way you can go, but then there's tunnels you can go down. You can jump up high and take the high levels, or you can go down low. It's not giving you a dotted line saying, here, follow this necessarily. So the best levels have a clear goal where you know where you're heading, you know what your ultimate goal is, but you don't necessarily know the path forward or the solution. And ideally, as you go level to level, your players should learn new skills and need new skills. So, this could be maybe for, in a game like Mirror's Edge or something, where you need a new parkour move to pass a certain part of a level, and now you're going to be using that parkour skill on future levels. Or maybe it's, a new attack that you're going to have to learn. But as you progress, typically your player needs to learn and adapt new skills, and those skills are going to be needed as you go forward on levels or level to level. And there should be surprises, things that you haven't seen before, right? New enemies, new types of enemies, new threats, whatever it may be, right? Or new goals, new quests, new treasures, whatever it is. So ultimately, you want to empower your player. You want to give them the ability to make decisions, and those decisions should have short-term, immediate, and long-term benefits or consequences. So maybe I can build this really simple weapon now, and I have an immediate benefit. But long term, now I'm not going to have those materials to build a much better weapon in the future, right? So that's how you empower your player. You give them those choices that may have both immediate and long lasting consequences and benefits. And that's one way in which you allow the player to control the difficulty, so to speak. So, there's one of the games, and I reference this game constantly because I'm actually not a huge video game player. So there's only a handful of games that are good in my book that I want to play. And one of them that I played, have, put in at least 1,000 hours into, is Dead Island. And, but it's a lot of games are like this, where you have a main quest, but then you also have side quests. And those side quests, when a player gives you a side quest, those side quests oftentimes tell you how a difficulty level of it, right? This side quest is easy. Oh, okay. I'm a wimpy player. I'll take that easy side quest. And another player gives you a side quest that's like suicide level. You're most likely going to die if you take this side quest. Well, if you're a more timid player, you don't want to do that, right? It allows you to avoid that. But again, getting back to number 6 here, that will have long-term benefits if I do take that side quest. I'm going to gain the experience. I'm going to find some cool stuff, and I'm going to, I'll reap those benefits and rewards long-term, right? So that's, these are ways that you can control player difficulty. The easiest way that a lot of games use is just right at the start. You start easy, medium, hard, suicide, and now some games are adding an even a 5th level of difficulty they just call 2020, right? And then, your levels should also be, again, getting back to Dieter Rams' principles for design, you want your levels to be efficient, meaning that, if you design, let's say, an island, like for Dead Island, you want to use most of that space. If you're putting the effort into designing it all, you want those to become parts of the game, places, areas that your character needs to go to in order to complete all of their goals. So that's what's meant there by efficient. And then ultimately, you do want your level to, or even parts of your level to evoke certain emotions, right? you walk into a hotel room and you see everyone's been torn to pieces, right? There's an emotion that should be evoked from that, right? Versus, walking into another area and seeing your friends are there that you thought were dead, and oh, they're back and they're alive, and woo. So, and we'll get into some of the ways of evoking emotion as we move forward. I want to move on to assets now. And this is an area, for those of you who've heard me speak about game development before, this is an area that I really tend to focus on. It hits very close to home for me. I had worked on one of the biggest game projects that I worked on was for Ally Bank. And Ally Bank was releasing this game at an international event. And so the deadline was hard. There was no moving that deadline. They weren't going to, change this big event, right? We had to launch the game on that day. And my team, which was, ended up being myself and one other person, really had 20 days to build this massive game out. But we were working with the client was working with a 3D artist that was going to be providing us with some of the assets. And what ended up happening was, we were scrambling, we were working with our own assets and scrambling to get the game to work, but then ultimately we're going to have to kind of rebuild and redesign everything once we got the client's assets. Well, we finally got their assets and they were unusable for us. And so this is why I always focus on this in these game development talks. It is so important that you understand this going in. There is a big difference between game assets that are designed, or assets, I should say, 3D assets, for example, that are designed for photo rendering versus in-game live rendering. So this here is just an example I found on the web. This is a model that has approximately 30 million polygons, and it looks beautiful, right? There's all this detail, and it looks great. And you send this to the server farm and have it rendered out and get it back, a couple of days later, and it looks beautiful. Right? But you don't want that when you want real-time rendering, right? Like in a video game, or even worse, in VR, where you're actually rendering the scene twice from two slightly different angles for the left eye and the right eye. So in VR, it's even more so, where you're actually rendering the scene, real-time rendering the scene twice from two angles. So for this, you want to make sure your scenes have much fewer polygons. And there's rules of thumb based on device that we can get into, I get into in my courses. But it's very important. So you could see here on the bottom, the actual lines of these polygons. There's not millions. There's maybe 10,000 max here in this bottom one. And that's what you want to look for. Now there's ways of taking these low polygon models and making them just as detailed as the high polygon model. And we'll get into that as we move forward. So one of the ways in which you do that is by using what are called different levels of detail, or LODs, LODs. So, for the same model, you might have, 4 different versions as here in the example, so that when this object is close up to the viewer, right? When it's close up to the player, you're going to use that highest LOD, that highest level of detail. Maybe it's got a few thousand polygons, and it's a little bit more expensive to render, but you're only rendering things that are close up at that level of detail. Things that are further away, you render at these lower levels of detail. So, maybe only hundreds of polygons, and they're way less expensive to render. So, when I say expensive in this regard, I mean taxing on the system, right? You have a video card on your computer or a video chip in your mobile device or what have you that needs to do all of these calculations, trillions of calculations a second in many cases. So you want to reduce those number of calculations to make your game smoother and more responsive. And so we talk about that in terms of expense, like how expensive is it to render this versus that. So let's see. Yeah. So I know my video is blocking the bottom right text here. Just basically, like you have high lot over here, you have low lot on this side, and this is 750 polygons, low detail for distant objects. So rather than going and hiding everything, or moving my, I guess I can, sorry, I can always turn my video off for some of these. Like so. Yeah. Okay. So one of the ways in which you add back these details, right? If you want to gain great detail on a very simple surface with not a lot of polygons, you can add, two of the ways are adding bump maps and displacement maps. And so a bump map, as you can see here in the center here, what that does is it just adds like a little bit of texture. It allows the lighting to cause shadows and highlights based on a texture, but it's actually not changing the shape of the object. So in this case, in the case here, we have a sphere. We add a little bit of visual texture to it, but it's not actual real texture. So in the cylinder here on the left, where it says bump map, that it looks it looks kind of like it's stamped in or out, but it really is just shading right on the surface. It's just done visually. Whereas a displacement map is a little bit more complicated because it actually does displace the surface. So it's still using the same number of polygons, but it's saying, hey, push this area in, pull that area out. And you can see that on the edge here, that these are actually causing, mountains or valleys, if you will, on this spherical surface, or these actual checkerboard bumps and text bumps on this cylinder here. So bump and displacement maps, these are good terms to know, especially if you're getting art from a 3D artist and you say to them, hey, I need low polygon artwork, and they're like, well, I can't do detail. You say, well, just add, give me bump and displacement maps. So that's a great way to add detail at lower expense. So all right, throw my camera back on. So now we get into art, right? And so assets is more general, but now art is getting into more specifics. Like there's character art, there's level art, there's all kinds of art. And one thing I really just want people to focus on is the style. Like pick a style, right? Is your game going to be, 8-bit style like Mario? Is it going to be a more cartoony style, a more semi-realistic style, right? Pick one of those styles, pick a genre, if you will, and stick with it, right? You want to make sure that your style matches throughout the game. So if you're using something very cartoony and then you have like a real model of a car in there, it might look weird, right? Texture maps. These are what get wrapped around models to give them texture, to give, to make them look as, whatever style or texture you want. And I always enjoyed these when I was first starting out in game development, because a lot of times these are just, maybe JPEGs or PNGs. You can open them in Photoshop, edit them. Like this one, sometimes they look really weird because it's taking a 3D object and it's stretching it out into a horizontal plane, and that's always disturbing. It's like, you look at a map of the Earth and, in your typical Mercator projection that you used to growing up with in a classroom, Greenland looks massive, and Africa, which is close to the equator, looks relatively small, whereas really Africa is the second largest continent. You could fit the North America, South America, Australia, and Greenland in there. Africa is huge, especially relative to Greenland, which is just an island. So if you look at it on a globe, you get the right sense of scale. So with displacement maps, a lot of time, or texture maps rather, a lot of times things get stretched out, they get distorted, they look weird. Um, but it's fun. You know, you can go in, say in Photoshop, and change the color of this guy's eyes, and then save it, and in your game he now has a different color eyes. So those are always fun to play with. In terms of art, there's lighting. There's all different kinds of light, spotlight, and we get into this in depth in my longer course, but I'm just going to rip through it here. There's spotlight, point, directional, which usually is what you use for sunlight, area light, volume light, and then ambient light, which is very important for making your games not look flat. One of the things also with when I was working on Ally World, a lot of times when I work on a game, I build the game out, I make it work, I build out the levels, and in the end I tweak the lighting and the shading and so forth. But until then, it just looks very flat. It doesn't look real. It doesn't look as exciting, and part of that is just really working on the ambient lighting and some of these finer tune things. But if you have a client that wants to see your work as you go, sometimes it pays to actually add some of these things in along the way, so that the game looks finished and polished before they ask to before you have to start showing it to them. Another important thing are shaders, and these are properties of every surface that control how the light interacts with those surfaces. And I just want to, this is a great example that my son likes to point out. Comes from Minecraft, and the top is your typical Minecraft surfaces with no shaders applied, and then the bottom is when you actually apply shaders. So these are somebody actually wrote shaders, and shaders are actually usually have code in them, right? That actually code out how the light interacts with the surface from different angles and so on and so forth. So far, everything that we've written in a lot of gaming systems, they just get placed, dragged, dropped, so forth, and there's no real coding involved. But once you get into shaders, that's when you can use pre-built shaders. But if you want to write your own, that's where some coding starts to come along. And then another fun part for me is visual effects and particle effects. So particles are often used, and particle physics are often used in games to add all kinds of effects, whether it's something like snow or dust blowing in the air, or smoke, or leaves blowing off a tree, to explosions and lightning strikes and all kinds of crazy wizards and spells and whatever, or even level up animations, right? Your character goes up a level, and they a glowing ring appears around them and floats off or something. So those are always really fun, and we'll work with those a lot in the course. And then there's animation, character animation, and others. These are bipedal animation. So oftentimes in game development, your characters are either bipeds, meaning they walk on two legs, or other, right? And we have a lot of pre-built stuff for the bipedal characters and for quadrupeds, like four-legged animals and so forth. Another really fun thing, I really enjoy this, is something called character rigging. And I apologize for the low quality version of this graphic, but it was the most fun version of this graphic you could find, where you can get a character, a fully designed character, and then you basically add a bone structure to them. So imagine like a big rag doll, right? And then you go in and you add like bones and joints to it. So now you can pose the rag doll and make it pose into different poses or whatever. Well, what's cool in game development is once you add these bones and joints, and especially if you use standard set, like this is a bipedal character, then you can apply your biped animations to this without having to go in and animate like frame by frame like you used to have to do in like cell animation. You can just say, oh, I built this animation one time, I rigged my character now, apply that animation to it, and boom, you've got you can animate this character. You can have 100 different characters, you rig them all up, they're all bipeds, you apply the same animation to it, and you can get them all walking in step. Very cool, very fun to work with. Cameras can be really interesting to play with in game development. These are another object that get animated that have all kinds of properties to them. You know, what's the focal length of the camera? What, how, where's the camera pointing? Right? Are you top down? Is this a top down game where the camera's always looking from above and you're running around like a rat in a maze, or is it first person, so the camera is always basically where your eyes are, right? So you can have a character and you basically put the camera at the end of their neck where their head would be, for a first person game. Or maybe it's a third person and the camera just kind of sits off right behind the person so you could see them, their full body when they're running, moving, fighting, whatever. But that camera is still rigged to them, but maybe programmatically, so that when they move into tight spaces, the camera moves in, and when they're running really fast in a wide open space, the camera pulls out. So a lot of times you can actually write code to control the camera, to make it move in and pull out. And then with cameras, you also get what are called clipping planes. So everything that the camera can see has to be rendered. So you want to limit what the character can see, and in this case, we're limiting it to everything that's in this area here, right? So in this case, we have a near clipping plane, which means everything that's closer to the camera than this, right? Maybe that near clipping plane is right here, and so anything closer to the camera, you don't want to render. And then there's a far clipping plane, which is like, how far can your character see? I've seen a lot of mistakes made with this, where if your character's spending a lot of time indoors, you usually want that far clipping plane to be close, because there's only so far you can look when you're indoors, right? You can only see so far, right? Down a long corridor, say, right? But when you're outside, do you want to be able to see the mountains off in the distance? You may want to be able to see much further and render those objects much further. So there's a trade-off here in expense, right? The further out you put that clipping plane, the more stuff you have to render between the camera and that far clipping plane. You have to render everything in that path, or at least do calculations. Can the person see this? Can the camera see this? Or is it behind a wall, right? So you have to do calculations out that far. But, it's a trade-off, because you want to pull that in to make your rendering less expensive. But you also want it to look good when you're outdoors, where you can see the mountains and so forth. So oftentimes you might want to make this dynamic in your game. If you're going, let's say your character's moving between indoors and outdoors, or make it scene specific. So if there's a scene where your character's in tight quarters indoors, maybe it's, they get into a little fist fight with somebody at a bar, right? And so now you can tighten up what the camera is going to focus on, but then afterwards they get thrown out the window and now they're outside and they could see snow blowing off the mountain caps, 2 miles away. So this is something you really want to think about, maybe make dynamic, maybe move, change from scene to scene. We play in the next class, we're going to play with this a little bit, where we take a camera from an indoor scene to an outdoor scene, and then you can see what happened, how the mountains disappear or reappear based on this clipping plane. All right. Number 5, music and sound. Music and sound is so important in a game. I mean, who doesn't know the theme to Super Mario Brothers by heart, right? Everybody knows that, right? You can hum a bar from Super Mario Brothers, and people will know what level you're in, right? Are you underground? Are you above ground? Are you, did you just get one of the invincibility stars, right? So sound is so important for evoking emotion, and And there's really 5 different families of sound that go into a game in developing a game. There's dialogue. So some games have actual spoken dialogue, right? This is where all bases are belong to us comes from, if for those of you who are familiar with that meme. There's music, right? Like the theme song from Super Mario Brothers. There's also sound effects, right? There's a sound that's made when you collect a coin, or when you get a mushroom that makes you grow, or when you die, or when you kill a Goomba, or whatever the case may be. So these number 2 and number 3 are used almost in every game I could think of, right? There's the background music, and then there's the sound effects, right? Not every game has dialogue, audible dialogue, but some do. The better games, your AAA type games, will also have what are called Foley sound effects. These are the sounds that you hear. People. I love Foley artists in movies, right? These are the sound effects of, like, the foot crunching on the gravel, or crunching on the sand, the grass, or versus sand, right? This is glass breaking when you get thrown through a window. These are the sound effects that aren't necessarily event based, but aren't background sounds. They're triggered by something, right? So they're triggered by an event like a sound effect, but they're more ongoing. They're more in the background, right? It's kind of somewhere between 3 and 5, which 5 is the ambient sound, right? The sound of the forest, the crickets chirping, the wind blowing through the leaves, traffic in the background, whatever. So there's the sound effects number 3, which is like, when you kill the bad guy, ding ding, whatever, or you level up sound or whatever, versus the ambient sound, background traffic, versus Foley, like when you slam on the brakes in your racing game, you hear the rubber screeching on the asphalt, right? And it should be based on the type of tire on your car, the type of surface you're screeching on, those kinds of things. So oftentimes those Foley sound effects are somewhat based on physics, and they can go from very simple to very complex. So those are the 5 different sound families. But why do you use sound in a game? So this comes from Callahan. What is the purpose of sound? So number 1, sound can be narrative, right? It helps tell the story. Number 2, it can help focus your attention. As I mentioned in Dead Island, there's a type of zombie that screams off in the distance when it sees you. It can see you from a really far distance, but when it does, it screams, and then it comes running at a really fast clip. So when you hear that scream, whoa, does it get your attention? You're quickly looking around. Oh crap, where's that zombie coming from? Right? So great at focusing attention. Sound can also define space, right? You can change from like short, quick echoes to deep, reverberating echoes. And, it can give you that sense of like a very tight, narrow space to like a big, wide, open space. And the types of sounds you hear, like a dripping water echoing in a narrow corridor versus, traffic way off in the distance, and birds chirping and wind rustling through trees, giving you a more open feel, right? It can also set a mood, right? The type of music that we're playing, right? Is it high energy music? Is it really fast paced and frenetic? Or is it more calming and soothing carnival type music? Where you're like, oh, this is fun. I'm going through a fun game. So you can really, use it to create intensity and action, or to create calm. So you could definitely play with the mood, or just emphasize certain things like the intensity of action. Right? It's good for setting the pace. So the pacing, the beats per minute of the music, if you will, the intensity of the music can also give you a sense of pace, and can help smooth transitions, make the game more immersive. And all right, so moving on, the user interface, or some people call it like the heads up display. So I always think of, the Iron Man when he puts on the mask and he's got, the heads up display in it. Um, when you have good user interface, it should convey relevant information. That information should be clear and obvious. It should also be simple and out of the way. You don't want, your health bar right across the middle. You want your health to be tucked away off on the side where you can glance at it or maybe see it out of the corner of your eye, but not like across your field of vision, right? And you don't want it to be overly complex, right? More complex than necessary. So I show this example here, not because I love this graphic here or necessarily love this graphic here. It's because they show the car crashed up here, right? Forget this graphic. You could see the condition of your car right in front of you, right? They made it part of the game. So your health of your car in this case is very visual, very visible to you. There's all different kinds of UI types. There's ring menus where you can flip around and choose something. Life meters everyone's familiar with. Usually inset maps that show you where things are on a level. There's a futuristic overlays like the in-helmet style, like Iron Man. There's sometimes gadgets. There's sometimes physical limitations. It's oftentimes similar to a health bar, but maybe it's your stamina going down or some other limitation. Scrolling text, selection auras, right? Where an area is highlighted. Racing lines, sometimes showing you like the ideal path to take in a racing game. Object labels, field of view color filters. So this is like, it might flash red when you've been hit, right? To show you, or grime, like I showed you on the card, indicating damage. Sometimes it appears on your first person screen. And, moving along, now we get into the behavior of the game. And there's all different kinds of behavior. Part of it is physics, right? And, this is one of the reasons why I think a lot of people, when they decide they want to become a game developer, they go right into programming because they think like, oh, I have to program all this. Game physics engines exist, right? These are out there. You don't have to write these. A lot of times you can just use existing ones unless your game is going to be based on some completely different kind of physics that nobody's thought of yet. But most game engines already have 3 different kinds of game physics. They have rigid body dynamics, which is described in the diagram here, which I'll just go through. Soft body physics, like, imagine a ball hitting a cloth, right? That's more soft body, right? Or particle simulations, as I talked about before, smoke or leaves blowing off a tree or whatever. But for the rigid body dynamics, which is really the big one, there's this loop that it goes through in every frame. So it starts off, you take all your objects in your scene and you apply whatever forces are on them from what's going on in the game. You update their positions and their velocities, right? So if you have a car and you're applying a force to push it forward, right? You update its position and its velocity. You detect if it collides into anything. And we'll talk a little bit more about colliders in a second. You solve for any constraints like, oh, it wants to move forward, but there's a wall there. It can't, right? So those different constraints that you have. And then you display those results. So, okay, now that I've calculated the position of all my objects now, I applied the constraints, detected collisions, now I display it in those new positions. That's one frame. Every frame of the game, oftentimes 100 or more frames per second, you're going through all these calculations in a loop, right? And now that everything's in a new position, there's new forces, there's new collisions to detect and so forth, every single frame. But this is usually built into your game engine. So how do we detect those collisions? So objects have what's called a collider. Colliders can be cubes. They can be, this is in 3D space. In 2D space, just flatten these to get the same idea. They could be cubes, they could be spheres. One very common one that's used is a capsule, like you may be able to make out here. over this character, and then a mesh, which is a much more complicated version. And you might look at this and be like, whoa, why would I just want this simple capsule here when I could do this and have this mesh? Like, that's way more complicated, right? Especially if you're looking at like collisions on their feet when they're walking and so forth, right? But oftentimes you want some kind of hybrid between this. And the mesh is very expensive computationally. You're constantly having to do these expensive calculations every frame. So it's much simpler if your collider is something like a capsule. So what is used most commonly is something between these. And you'll see this in the next course that we do, where maybe the head is a sphere and maybe the arm is made up of capsules and the end of the hand is a sphere or a some kind of rectangle, and the feet are rectangles and the legs are rectangles. So you can still get a little more of this detail, where you can detect punches, you can detect kicks and things like that, and detect strikes on different parts of the body, much more, much less simple than this, but without having the expense of these mesh colliders. So these mesh colliders are good if, maybe you're doing some kind of game where, you need to hit a critical artery or something of this guy in order to kill him, right? That maybe he doesn't die from just flesh wounds alone. So then you would maybe want something more complicated. Or in the case of like a Super Mario kind of game where you just squash the Goomba, a cube is just fine. That's all the detail you need. It's one hit dead, right? If you land on the cube, the Goomba squashes. So you don't use anything more complicated than you need, right? Game AI. Game AI, so AI is for artificial intelligence. And I just want to give, like, as some of you might look at this graph and think it looks really complicated, let's walk through it. But this is really like basically the simplest non-player character you can have. So you've got this character here, bottom left, that is set to wander, right? So this character is wandering around your level, and if it sights the player, this arrow here, then it goes into an attack mode, right? So it sees your player, it chases them, and it attacks, right? If the player becomes, is out of sight, it goes back to wander, right? So real simple. If the player's in sight, it attacks. If the player goes out of sight, it wanders. But now what happens if the player attacks them, right? Then, so they attack the player attacks back, they now evade. Oh no, you're hitting me. So now our non-player character evades, and if they've been hurt, they can go and find more health points and, regain their health. And once they have regained their health, they could stop trying to find aid and go back to wandering. If the player's in sight, maybe they go right back to attack. Maybe there's a line missing right across here. If the player becomes idle, stops attacking them here, maybe they can go back and attack again. So, so this is just a really, basic AI. Okay. And the idea of an AI is to simulate intelligence, right? So you have this non-player character, could be an enemy, could be not an enemy, could be a cow grazing in a field, right? But you want to simulate some level of intelligence, right? So you give it these behaviors that, helps simulate, like, oh, there's an enemy, let me go attack them. That helps to simulate some kind of intelligence. You also need to give them the ability to find a path, right? So oftentimes when we design our levels, we'll also calculate what area in that level is navigable by our non-player characters. In other words, we set up rules that say, okay, well, the characters can jump this high, they can step down this far, they can walk up a slope that's a certain steepness. And you set up those rules, which are very simple. There's interfaces to do this. You hit calculate, and it'll go in and calculate an entire surface of where your non-player characters can walk. And then, so then the game AI says, okay, I have this surface I'm allowed to walk on now, a map, if you will. And what's the quickest way to get from here to that player that I'm chasing? And so they find a path through all across that navigable surface. So then there's decision making, right? This tree here, we're giving them very simple decisions, like if the player is idle, attack them. If you could see them, attack them. If they're out of sight, wander around looking for them. But there can be even higher level decisions, right? Like when you're attacking, what part of the player's body are you trying to attack, right? What weapon are you using? Maybe you give you make really complicated characters that have multiple weapons that can choose a weapon based on the enemy. So decision making can become much more complex. And usually we build, this little flow diagram here is very simple, but oftentimes these become like whole decision trees, like flow charts, if you will. And oftentimes in a game, these can be created by dragging around different things of a flow chart. You create an animation, you say, okay, if this happens, run this animation, exhibit this behavior. And a lot of this can be done just by dragging around different things in a game builder flowchart decision making tree. But oftentimes, big budget games will spend up to 50% of their game budget on this part, just on the game AI. So this is, if you're wanting to get into game development, if you're wanting to get into your own, you're a solopreneur and you want to create your own games, something to consider. This is where 50% of your game development should occur, is in the AI. Or if you're looking for a career in this, realize that maybe half of the jobs might be just in this, right? So not doing 3D modeling, not doing art, not doing lighting, but literally in tweaking the behavior of your non-player characters, right? That could make up to half of a game. And there's other behaviors as well that to consider with your game, right? Are there, what kind of reward systems do you have? How are you gamifying it, right? Are you, does your player get to go up levels? Does your player get experience points or collect coins? How does that work? What kind of enemies are you going to have? How are those enemies going to behave, right? Are you going to have skill trees or resources you need to manage, right? Do you run out of wood? Does your player get cold? Does your player get thirsty? So all of these different things that, you need to decide going into the creation of your game. And then number 8, which is, we're getting towards the end here, is testing. And I mentioned that a lot of times people say, oh, I want to be a game tester, right? And they have this vision of sitting around on their Xbox or their PlayStation, in their underwear, eating Cheetos, and just playing video games all day. That's one kind of testing. That's called quality control, QC. And in that, what you're trying to do is you're trying to break the game. You're literally trying to do things that other players might not try and do, because you're trying to find the bugs. You're trying to break the game and document the bugs. But this isn't just playing. This is, okay, if I take these 8 steps, I can cause this bug to occur. And then you have to document that. You have to be able to recreate it and document it and send that document in to the developers to fix it. So it's much more involved than just sitting around playing video games, right? You have to be able to find these bugs, be able to recreate them, and be able to document them. There's other kinds of testing, though. Testing things like, how does the game play? How is the game designed? How does it play in terms of game theory? There's testing the UI. What is the experience like? How does it feel to play this game? Can you easily see the health bar when you need it? Or for VR games, is it induce motion sickness? It's something that we'll talk about in our 1-week course a lot. Is talking about how to create a VR experience where you don't get motion sick. There's also automated testing. So and this gets into programming. um, your game developers should be able to create tests that run through millions of simulations, right? So, for example, I might want to know if I'm building out a game, what happens if somebody leaves the game on pause for a year, right? Might sound silly, but what happens, right? Well, I don't want to spend a year testing that, right? I don't want to set up a machine, hit pause, and run through it for a year. Or better yet, set up 100 machines, hit pause at different scenarios, at different parts of the game, and wait a year, right? But I want to know those answers. So what we do is we create code that simulates that goes through that simulation, runs through and simulates a year of being on pause, just as a silly example I'm coming up with, and can run through that scenario in 100 different, run through that test in 100 different scenarios. So you can create these automated tests that are written in code that go through and simulate all these different scenarios to see, if the game breaks in any of those scenarios. There's performance testing, security testing. So performance testing, does it lag? Security testing, can I break into another user's account? Things like that, or maybe hack it to get free gold or whatever. Compliance, is your game compliant? ADA regulations, other regulations, etc. Localization, this game works really well in certain languages, but as soon as you go to Israel, where they read right to left, suddenly the game breaks because all of the text was left justified, and it goes off the screen. Weird things happen, right? So you need to be able to test for these things, right? Compatibility. Maybe you're making an Android game, and there's a million different Android devices, different versions, different screen sizes, right? Does this work on all of them? So compatibility is really interesting. And then there's soak and load testing. Soak is kind of like the, keep the game running for a million hours and what happens. Load testing is more like, what happens if I get, 10 million people hitting my server all at once? And then, being able to play multiplayer. Does multiplayer function working, the network functioning working, etc. So that's just some of the kinds of testing. Finally, once you've got your game built, tested, it's ready to go, now the question is, how do you market this? How do you get this game into your players' hands, right? So to market and deploy a game, there's all different strategies. A couple that I really like to highlight here. Number one is you could set up a competition, right? Get some game players and host a competition. See who can beat your game first, or get the highest score, or beat each other, right? You can seed it out to influencers. One top influencer plays your game and posts a video on it, and boom, your game can go viral, right? Or get into, the app store as a highlighted game or something like that. Could be amazing, right? Seeding it out on streaming services, word of mouth, entering into gaming events or creating gaming events, creating behind the scene videos, the making of, right? People love those, and it can generate a lot of buzz. Or getting like a celebrity endorsement or a celebrity to play your game. These can all be really big. So this is a quick and dirty overview of, how to market and deploy your game. Ultimately, you're trying to get it to it's cut off, but it just says front page of the internet, right? Or Reddit. That's how you really win. But hopefully all of this gives you a better sense, quick and dirty introduction, 1 hour introduction on game development, all the different aspects that go into it. If you have any questions, please post them, post comments, like the video, subscribe, and don't forget to visit us at bocacode.com. Check out our upcoming courses. Thanks again to Palm Beach Tech, and I should probably change this so you can actually see their logo. So thanks again to Palm Beach Tech. Contact us, go to bocacode.com, join our Slack, sign up, and make sure you're back here Wednesday at 1 p.m. for the second part of this video. Thanks, everybody.